Welcome back, everyone, to our continued discussion of the theory and intuition behind logistic regression. In part 2, we're going to discuss the basic intuition behind transforming a linear regression to a logistic regression. So let's explore how to do that conversion, and specifically we're talking about converting a linear regression model used for a regression task that is predicting a continuous target into a logistic regression model used for a classification task, a categorical target. Let's start off by imagining a dataset with a single feature, the previous year's income, and a single target label, whether or not the person defaulted on their loan. So our dataset could look something like this. Here we have just a really simple value for their income. We can see that income can be both positive and negative, meaning in the previous year they actually drew more money from their bank account, so they had a negative income, or they added more money to their bank account, so they had a positive income. And then we can see whether or not they ended up paying off their loan that year. So a 0 indicates that they were not able to pay off their loan, and a 1 indicates that they were able to pay it off. And there's a clear relationship here between having negative income and not paying off your loan versus having positive income and paying off your loan. Let's begin by plotting out this income versus default. Now you'll notice something right away. Since we only have two possible categories for loan paid, where 0 is no and 1 is yes, pretty much all your plots are going to look like this regardless of what the actual income is. We'll always just get values at 0 and values at 1. So you end up with this categorical or binary relationship here. So we do notice that people with negative income tend to default on their loans. And you might be thinking, could we actually fit a linear regression to this to solve the task? So if we had to predict the default status given someone's income, and we were to fit a linear regression, it actually would not work. And you can recall Anscombe's quartet, where you have major issues with some points lying way outside as outliers. And clearly, with values only being able to be 0 or 1, we're going to have issues. And linear regression is easily distorted by only having either a 0 or 1 as possible y training values for a wide variety of x values. It will also be unclear how to interpret predicted y values between 0 and 1. Since here the regression line is predicting some value of 0.2, when we know, realistically, we just want either a 0 or a 1 value. What we could do, however, is make use of the logistic function we talked about in the previous lecture to perform some sort of conversion, to go from this linear regression fit to a logistic regression fit. So let's first focus on what this logistic regression would look like. What we're going to end up doing is we'll treat the y-axis as a probability of belonging to a class. And then we'll treat 0.5 as the cutoff point. So essentially what we're saying here is we fit out this logistic function, and we'll talk later on about the mathematics behind converting the linear regression to a logistic regression. But clearly now, using this sort of logistic function fit, we can see that if I were to choose a cutoff point at exactly 0.5, then I'm treating my y-axis as a probability, saying that the probability of y being equal to 1 is equal to where this lies along the y-axis. So for example, let's imagine a new person with an income of 1, noted there by the yellow triangle. I can see where that value of x actually intersects with this logistic regression fit. And then I would overlook to the y-axis, and I can see that it's 0.9. So essentially I'm predicting a 90% probability of someone paying off their loan if their income is 1. And since my cutoff is 0.5, then I'm going to say anything that's greater than or equal to 0.5 is going to be pushed up to be return of 1. So I'm saying I predict this person will pay off their loan, so I'll say loan paid off of 1. And later on, if I want to actually say how strong my conviction is of that prediction, I'll say that I'm 90% sure this will be the outcome. But how do we actually create this line? Fortunately, the mathematics of a conversion from a linear regression to a logistic regression is quite simple. In the very next lecture, what we're going to do is show you the actual process of taking that linear regression and essentially sticking it in to the logistic function to create logistic regression. So we'll see you in the next lecture where we go through the mathematics behind the logistic regression model, converting a linear regression to a logistic regression, as well as what this updated cost function would look like. I'll see you there.